Okay, last one is SAS. SAS says if two sides of a triangle are proportional to two sides of another triangle, and the included angles, what does that mean? Here I'm going to write it, angles between the sides, right? The included angles, or the angles between the sides, are congruent, then the triangles are similar. If two sides are proportional to two sides of a different triangle, and the included angle, or the angle between those two sides that are proportional, those angles are congruent, then the triangles will be similar. Okay, so I've labeled two triangles here with two sides and an angle. So to prove this, we have to show the ratios for the two sides, and then we have to show that the two angles are congruent. And that they're between. They have to be between. Okay, so which side do you think matches up with which, if they do match up? Sammy, which side do you think would go with the one labeled 3? Okay, DE doesn't have a number on it, so we can't create a ratio with that one. I realize it's in the same position, but we're kind of going with the sizes of the numbers instead of what the triangles look like. So 3 is bigger than 4. I mean smaller. 3 is smaller than 4, so which one do you think 3 would go with? No, because those are in the same triangle. We want to go with one number in one triangle and one in the other triangle. I'm trying to help you. So we have a number in one triangle goes with what number in the other triangle, because they're both the smallest? It's a 9. Okay. So 9 is smaller than 12 and 3 is smaller than 4, so 3 goes with 9. Correct? So AB would go with DF. So 3 over 9, what does that reduce to? David, what does that reduce to? 3 over 9. I just want a fraction reduced. 3 over 9. How do we reduce fractions? Find a common number that divides into both 3 and 9 and divide it out. Yeah, so 3 divided by 3 is, and 9 divided by 3 is 3. So this reduces to 1/3. Okay, now let's do the other set of sides that might line up. So BC looks like it might go with EF or FE. So BC is 4 and EF is 12. Who will help me reduce this one? Okay, divided by 4. James, what do we get? So divide by 4 is 1, divide by 4 is 3. I got the same ratio for both of them. So does that mean they're proportional? Yeah, what's the other thing that I have to show though? Angle B is congruent to angle F. And are those the included angles? Is that angle between the two sides? Is Is angle B between the two sides that we used? Yes. And is angle F between the two sides that we used? Yes, it is. So those are the included angles. So guess what we've got? Side, angle, side. So triangle ABC is similar to what triangle? DFE is what I heard someone say, and it is correct. A goes with D because they are both next to the shortest sides. B goes with F because those are the included angles. And C goes with E because those are both next to the longest sides. And our reason for knowing that is the side angle side similarity postulate. Okay, today you are going to be proving triangles similar. You are also going to be solving some problems using ratios, kind of like a few that you did last time, okay? So what you're doing, what I want to do quickly is go over another example of something you might see on your assignment today, something similar. Sometimes they make triangles similar by saying you have one triangle inside another one like this, and so they share that angle. And that tends to make them similar, especially if this is parallel to this. Then you'll get alternate interior angles that are congruent to, no, actually corresponding angles that are congruent. And so then the two triangles will be similar, the one inside the other one. So what if you had a problem like this and they told you that this length is 6 and they want you to find this, and this length is 5 and this length is 9. This doesn't have to be a mid-segment. This is just two similar triangles. If it helps, you can redraw them separately. So you have 6 over x, and then the bigger triangle would be 11 over 9. Where did I get the 11 from? I added the 6 and the 5 together to get the side of the longer triangle, correct? So now can I set up ratios to solve this? How do I do ratios to solve this? Tell me what to write. Alex, louder. Okay, 6 over 11, because those match up, equals x over 9. Notice since she went from small to big, the second time she went from small to big. You have to keep it the same way both times. If you decided to do 11 over 6, then you would have to do 9 over x. Or another way to do the problem, because of those proportion rules we learned last time, is you could do 6 over x and 11 over 9. Or you could do 9 over 11 and x over 6. There are actually 4 different ways to set up the problem that will get exactly the same answer. You just have to choose one of the 4 ways. Okay, so now how do we solve it? What do we do? What do we do to solve this? Cross multiply. So x times 11 is 11x. 6 times 9 is 54. Divide both sides by 11, and the answer is nearly 5, because 55 divided by 11 would be 5. So it's going to be really, really close to 5. I don't know exactly what. Did anybody get a decimal for me? I just made up these numbers, so 4 point something. Anyone? Calculators out. 54 divided by 11 for me. $54 divided by 11. So really close to 5, just like I said. I thought it would probably be about 4.9, but I wanted you guys to do it. Okay? Your assignment is on page 507. You're doing 20 problems.